So in yesterday's lecture, we have discussed about the subtopic 5.1, Introduction to Organic Chemistry. Okay, and then we have checkpoints that we haven't discussed yet. So we are going to discuss the checkpoint. Okay, so please check your answer with the one that we have in the slides. Okay, I hope everybody has completed the checkpoint. Alright, okay, question 1. Draw expanded structural formula for each of the following compounds. A, propane, then butanol, and then we have pentanoic acid. Okay, so these are the expanded version of the compounds. Okay, alright, so this is propane, butanol. Okay, so you have the carbonyl, group, and then you have the H there, don't forget. Okay, so for butanol, the homologous series is aldehyde. The functional group is carbonyl, but the carbonyl group must be located at the terminal of the chain. Terminal means at the end of the chain. Okay, all right. And then we have pentanoic acid. Okay, so it has 5 carbon in the chain. 1, 2, 3, 4, 5. Then we have carboxyl group again at the end of the chain. Okay, so compared to butanol just now or aldehyde just now, it has hydrogen, but for carboxylic acid, it has OH for the carboxyl group. Okay, right. Then checkpoint 2. Draw the condensed structural formula for each of the following compounds. Okay, all right. So what is given? What are given to you? Apa nama ni? The condensed version of the the expanded version of the compound. So you have to transform this into the condensed version. Okay, so you have to compress. Okay, so how would you compress all of this? Okay, so normally we would target the C, okay, but we can also start from the OH. Okay, all right, so if you target for the C, so we have 1, 2, 3, and then we have 4. Okay, just follow as is. Okay, follow as it is. So we have carbon, right? This we have the first carbon here. Okay, and then we have H2. Okay, and this carbon is also attached to OH here. Okay, so I would use OH in the bracket. Okay, and then we have another CH2, carbon number 2, okay, which is attached to 2 hydrogen. And then we have the third carbon, C. Okay, all right, you can present it as this way. Okay, CO, or you can also present it this way, OH, CH2, because it's the functional group then, COO. Okay, CO, and then next we have the last carbon here, the fourth carbon, and the 3 hydrogen attached to it, CH3. Okay, all right. So this is the homologous series is carboalkoxy. Okay, this is ester. The homologous series is ester. The functional group is carboalkoxy. Okay, how about this one? Okay. Okay, so you are going to compress this compound, this expanded version into condensed version. Okay, we may start from here. Okay, C, we have 3 hydrogen attached to it, and then we have this one, C, we have 1 hydrogen attached to it, and then we have 1 C attached to the second carbon here. Okay, that means how do we differentiate this one with other other carbons? Okay, because it has three hydrogen attached to it. So we might use the bracket. So this bracket, the carbon in the bracket belongs to this carbon. Okay, this second carbon. Okay, so you always have to make sure that the carbon has 4 bonds attached to it. Okay, and then next, this one is done. Next, this one, so we have 2 hydrogen attached to it. Then another 2 hydrogen attached to it. Okay, and then you have CN. You may apa nama tu, write ataupun you may show atau you may present the triple bond, or you can also apa nama tu, apa unshow lah. Okay, you tak payah show kan pun tak apa, you show pun it's not a problem because this is the functional group. Okay, you can also make this in parentheses, okay, because it is a repeating unit. So it shall be CH2, okay, and then this and a superscript, it's subscript 2, okay, after the bracket. Okay, how about this one? Okay, this one normally we will go for skeletal lah. Okay, we don't normally do. What's the answer for this one? Question 2 just now. No answer for this one. What's the answer for this one? Ya, tak ada. Question 2. Oh, this one lah. Ayo. Condense kan? Okay. Alright. So if you condense this, okay, you condense this one. This is question 3. If you condense this one, okay, so it will be C5, because this is cyclic, okay, cyclic, the ring. C5, 1, 2, 3, 4, 5, H5, and then this is a functional group, right? CHO. Remember, CHO. This is carbonyl, or the homologous series is aldehyde. Okay, so don't do this COH. OH is for hydroxyl group. So HO is for aldehyde, for carbonyl. Okay, all right. Moving on to skeletal. Okay, so skeletal, so you have to transform this into skeletal form. So 1, 2, 1, 2. Okay, so we have this. Okay, 1, 2, 1, 2, and then we have O. Okay, so this is carbon number 1, this is carbon number 2, and then don't draw the O here. Okay, don't draw the O here, so you need another arm for that. P lah. Okay, you need another line for O. So you should be doing this is IU. Yep, O. Okay, all right, so 1, 2, 1, 2, and then O, and then O. Okay, and then C. Another C, okay, another line, and then C. This is the third C. Okay, and then the fourth C. Wow, very heavy rain. Okay, what tool? C. And then this is number 4. Okay, then this is number 4, and then we have number 5, and 3, 4. This is number 5. 5, 3, 4, 5. Okay, all right. So you can either do this, or alternatively, because this is carboxyl group, the carbonyl, and then the OH. See, this is the fifth C, fifth carbon. Then you have oxygen, and then you have OH. Then we have OH here. Don't forget. Make sure you have. Make sure to check your final skeletal formula. Okay, to make sure that you don't miss anything. At carbon number 2, we have OH. Yeah. Okay. All right. So that will be for A. How about for B? Okay, for B, okay. All right, so to those who are not familiar with condensed still, okay, my suggestion would be you try to expand it first. Usually from expanded, okay, to transform from expanded to skeletal, it will be easier. But from condensed to skeletal, sometimes it can be tricky. Okay, it can be tricky sometimes because dia condense kan. Kadang-kadang repetitive unit tu dia pakai bracket. Okay, so kita mungkin miss out something. Okay, so you kena assign. Okay, so we have CH3 here. We have 2 CH3. So this CH3 belongs to, dia sebenarnya attached kepada siapa? Attached to this one. Okay, so as if like we have this C. Okay. And this C is also attached to hydrogen, right? Okay, so hydrogen. So we have CH3. Okay, CH3. See, that's why you have 2 CH3 there. Okay, all right. So this carbon is now settled. Next we have CH2 kan? So we have CH2 and then see this one. Suddenly CH. So ni kenapa dia macam tu? Macam tak cukup je tangan dia ni kan. As if. C. Then suddenly CH. C. And then H. Ni macam tak cukup ni. Dia kena make sure that they octet. Okay. Alright. So most likely. Okay. Very, very highly that here we would have triple bond there. Okay. Don't just simply add in hydrogen because you want to octet the carbon. Okay, don't do that. It is, you have to consider other option that the bond maybe the carbon may contain double bond or triple bond. So in this case, it has triple bond because if we have triple bond, these two will be octet. Okay, then it will be easier lah for you to transform into to skeletal. Okay, so nak transform into skeletal, 1, 2, 3, how many carbon? 1, 2, 3, 4, 5. Okay, go for the straight chain first. Go for the straight chain first. Okay, so we have 5 kan? Right, 1, 2, 1, 2, 3, 4, 5. Always count back your carbon. Okay, 1, 2, 3, 4, 5. Okay, carbon number 2. Carbon number 2 here, we have CH3. Okay, so this is how you should represent your CH3. Like this, just a simple line there. Okay, because this represents C. This N represents C. And then another H. Of course, H will not be shown. Okay, all right. Okay, again, so this is CH3 here. Okay, and then next, we have triple bond. Okay, triple bond. 1, 2, 3. Yep, this one. Okay, so this is triple bond. Okay, all right. So done for B. How about C? Okay, so this is again cyclic. So we have 1, 2, 3, 4, 5, 6. 1 hexagonal. 1, 2, 3, 4, 5, 6. And then we have CH2, CH. Okay, so this C as if, okay, let me expand this into, so it has H, and then one hand will have CH3, and then the other hand will have another CH3. That's why it has 2 CH3 in bracket. Okay, so this is how it looks like. Okay, so how would you draw it in terms of skeletal? Okay, so we have 1, 2, okay, 2 carbon, and then 3 carbon. Go for the straight chain, guys. Go for the straight chain. And then the rest will be the branch. Okay, 1, 2, 3. So 1, This is number 1. Okay, this don't count from here. Okay, guys, this is hexagonal punya carbon. So you're gonna count from the external part, external carbon. So 1, 2, 3. 1, 2, 3. Okay, don't overlap dekat sini. This is one yang 6 carbon tu. Okay, yang 6 carbon. So if you come from here, so nanti ni konflik lah. Ini kan yang hexagonal punya. Then why suddenly you overlap dia punya carbon as the apa nama tu yang dia punya chain, the external chain. Okay, don't do that. Okay, so you're gonna extend one more line, 1, 2, 3, and then at carbon number 2 here. Okay, carbon number 2, this one you have CH3, right? Okay, you don't write. Okay, if it is fully skeletal, this is how it is. So this is CH3. Okay, so this is CH3, this is also CH3. So this is the same as the expanded just now. Okay, this way. Okay, next, another checkpoint. Classify the following as either electrophile or nucleophile. Okay, so this is very easy. We have charge, positive charge there, therefore it will be electrophile. Okay, Cn minus, this will be nucleophile. CH3, COCH3. This would be electrophile, I believe. Okay, this will be electrophile because this is how it looks like. Okay, C double bond O. Okay, CH3. C double bond O, CH3. So this is electronegative. So this carbon will be slightly positive. Okay, so this carbon will behave as electrophile. Okay, all right. Then CH3, CH2. Okay, so you have to check for the double bond. Okay, so this is here is likely to have double bond. Okay, C, double bond C. Okay, we have H. Here, double bond. So double bond is not shown. So that's why you should know. You should know. Okay, you kena tahu. You kena aware that carbon must follow octet. So looks like dia tak follow octet based on this condense, but it's just that the double bond or the triple bond is not appear. Dia tak appear, tapi dia ada. Yeah, because it's not necessarily to show the double bond or triple bond. You kena tahu sendiri. Then we have 2 hydrogen. Okay, so we have double bond there. So if we have double bond, it is also one of the characteristic of nucleophiles. Okay, you have to refer to the list of nucleophile and electrophile lah. Yeah. Okay, checkpoint 3, and then question number 2, identify the following reaction as homolytic fission or heterolytic fission. Okay, so homolytic fission will produce free radical, whereas heterolytic fission will be producing ions because both of the electron shared will be given to the one atom, to only one of the atom. Okay, to one of the atom only. Instead, kalau homolytic, on the other hand, okay, both electron will be each electron will be written back to its owner. Okay, fair and square. All right, so that's why you will produce free radical for homolytic fission. Okay, okay, so this is heterolytic because the ions are produced hetero, and this one, okay, this is free radical. Okay, so this free radical will attack this normal molecule to produce free radical. So it is a homolytic fission sebenarnya. Homolytic fission. Ni sebenarnya not as easy as, you know, combine lah. Okay, this one should be broken down first, returned back to the owner. Okay, and then only it will form bond with BR. Okay, so this first, okay, this of course will attack, and this will be broken down through homolytic fission. Homolytic fission, maksudnya return back to both of the owner. Okay, and then only the H, the free radical of the H will combine with with BR to form HBr. So this is homolytic. Okay, when you produce free radical, it will be homolytic. Right? Yep. Homo and hetero. Okay, moving on. The last question, I believe. Classify the following reaction as addition, elimination, substitution, or rearrangement. Okay. All right. So so we have double bond there, and then we have HOBr, and then as you can see, you only have one product. Okay, we only have one product produced. So obviously, this will be addition, because initially we have two reactants, now become one. So the two reaction has been combined. Has been combined as in the addition reaction. Okay, so one of the reactant has been added into the other reactant. Okay, so this will be addition. Okay, next. Okay, initially we have two. The product also we have two products, but this time around, okay, so this one, CH3. Okay, so this is hydroxyl group. Okay, this is hydroxyl group. If you were to expand, you will get this structure. Okay, you will get this structure because you ada tiga kan. Okay, to this carbon, then you have OH. Yeah. Okay, and then you react with HC triple bond N. So what happens is that this OH will be removed and replaced with this CN based on the product form. This OH later on will combine with the hydrogen from HCN. So this is a substitution reaction because OH is now being replaced with CN. Okay, with cyano group. So this is substitution. Okay, all right, C. Okay, so initially we have one product, one reactant starting material. Next we have it produced two. After reaction, we produce two products. Okay, all right. So this would be okay. So you have to identify whether it has double bond or not. Okay, so most likely we have a double bond here. Okay, so when you try to expand it, try to expand this structure, you will get this C. Okay, we have CH3. So this CH3 is attached to this C. And then we have hydrogen also attached to the same C. Okay, and then we have addition, elimination. This is elimination lah, very obvious one. Okay, this is elimination sebab initially we have Br kan in the compound, in the molecule, then you don't have it in the product. You don't have it in the product. Okay, so you nak expand pun boleh, tapi the key is to check. Okay, if it's elimination, that means initially we have it, then after we don't have it anymore. So it's elimination. Okay, elimination lah. Okay, and then next. Okay, look for the OH. Okay, look for the OH. So initially it's at the end of the chain. Then suddenly it changes the apa nama tu, the place, okay, to carbon number 3. Initially it is attached to carbon number 1. Now it is attached to carbon number 3. So this is rearrangement. Okay, right. Okay, it's Azan here, guys. Let's have a 2 minutes break. Okay, we will continue after this. Okay, all right, so let's continue with 5.2, isomerism. Okay, so these are the learning objective that you should know for this subtopic. Okay, make sure that you cover it all, cover them all. Okay, so isomerism refers to two or more compounds having same molecular formula but different arrangement of atoms. So previously, we have learned about the chemical formula, okay, how to represent the organic molecule. So we have chemical formula, right? And also skeletal, as we have uh, structural formula. Okay, we have structural formula. And structural formula, we have a few of them. We have expanded, we have skeletal, we have condensed, and also 3D. Okay, right. So these are ways to represent the organic molecules. Okay, so we are going to get we are going to get into detail Okay, we want to know based on this given chemical formula whether it has isomers or not. Okay, whether it has like adik-beradik lah, like sibling, having the same formula, chemical formula, but different skeletal, different structural formula. Okay, right. So isomerism refers to a more compound having same molecular formula but different arrangement of atoms. Okay, so isomerism can be divided into two: constitutional isomerism and also stereoisomerism. I believe the one that you have learned in school last time is this one. Okay, constitutional isomerism. So constitutional isomerism can be divided into three. We have chain isomerism, positional isomerism, and functional group isomerism. On the other hand, stereoisomerism, okay, we have two of them, which is geometrical and also optical isomerism. So this is totally new. Okay, this is totally new. This is the one that you have learned. Okay, so a very quick recap on constitutional isomerism. What is constitutional isomerism? Okay, compounds having the same molecular formula, but with different structural formula. Like I said just now, okay, with different structural formula. So there are three types. It can be chain or branch or positional and functional group. Okay, so they differ in the kinds of bond and or in the connectivity of the atom. Okay, where we could play around with the chain or the position of the functional group, or even the functional group, okay, can also be altered to something else, but as long as it obeys the molecular formula, therefore it is considered as isomerism. Okay, as isomers lah. Okay, so this is example of chain ataupun branch isomers. Okay, the different structural formula due to varying length in its carbon chain. Okay, for example, so this is the chemical formula, kan? So as what I've told you earlier, okay, previously, what chemical formula tell us is that how many atoms are in the molecule, and also how many atoms and the type of atom that we have in the molecule. So in the atom we have carbon, in the molecule we have carbon and also hydrogen. And how many carbon do we have in it? We have 6. And how many hydrogen we have in the molecule? 14. But how they are arranged in the molecule, we don't have that information. So this is what we call isomerism. Okay, so we may arrange them into few structural formula. So inilah yang dipanggil isomers. Okay, so we can vary them in terms of chain. Okay, so initially paling senang, we have a straight chain. Okay, straight chain of straight carbon chain where we have 6 of carbons. So this is called hexane. Okay, this is called hexane. So still obeys the C6H14. And then alternative to this, we have one branch. Okay, one methyl group at carbon number 2. Okay, so this is called 2-methyl pentane. Okay, so this is not the same as this one. This is not the same, but they have the same chemical formula. The structural formula is not the same. Same goes to this one. So when we rearrange the carbon into other locations, so we got this structural formula. So this is known as 2,2-dimethyl butane. Okay, again, this is not the same. These three are not the same molecule, but they have the same chemical formula. Okay, they differ in terms of carbon chain. Maksudnya dia punya number of carbon chain tu different. So this one straight chain dia 6 carbon. Straight chain this one is 5 carbon. This one straight chain dia 4 carbon. That's why it meant by that is what it meant by varying length in carbon chain. Okay, that is in terms of chain. And then Another one is chain isomers have different physical properties. Okay, still for chain or branch isomer, okay, they have different physical properties, but they have similar chemical properties because they come from the same chemical formula, but the physical formulas are different. Okay, like pentane here, C5H12. Okay, pentane have melting point 130 degrees Celsius, but isopentane, which have the same chemical formula, the melting point is a little bit higher, 160. Okay. All right. Next, we have positional isomers. Okay. Molecules have same carbon chain and functional group, but differ in the position of the functional group. This is in terms of positional isomer. They have the same functional group. Okay, they have the same functional group, but they differ in terms of the position of the functional group. Okay, all right. So this is a chemical formula. So it is obvious that we have hydroxyl group in the molecule. Okay, so for the first structural formula, we have OH hydroxyl group at carbon number 1. Okay, and then alternative to this, we have OH at carbon number 2, and then it is called 2-butanol. So this is what we call positional isomers. Okay, the position of the functional group is not longer the same. Okay, it's not the same lah. So it changed from 1 to 2, 2 to 3 to somewhere else. Okay. Okay, positional isomers have different physical properties, but they have similar chemical properties. So similar to chain isomer just now, they have the same chemical properties, but different physical properties. Because why? Because they have the same functional group. Okay, same goes to this one. Okay, so this is 1-bromopropane. The bromine is located at carbon number 1, and then next we have bromine located at carbon number 2. So as you can see, the temperature, the boiling point is not the same. Okay, but they do have the same chemical properties. Right. Next we have functional group. Okay, molecules have different functional group and or homologous series, hence their structural formulas are different. Okay, they have different functional group. They have again the same chemical formula, C3H6O, but the way they can be represented, okay, and the way that they can be represented, one is as aldehyde, the other one is as ketone. Okay, tapi both of them also satisfy this chemical formula. Dia tetap ada 3 carbon, 6 hydrogen, 1 oxygen. It's just that ini sebagai they have the same, this one dia punya functional group is the same, carbonyl, but dia punya homologous series is not the same. Okay, so this is aldehyde and this one is ketone. Okay, so this is what we call functional group isomers. Boleh berubah-ubah isomers ni. Okay, another example. Functional group isomers have different chemical and physical properties. Okay, for functional group, okay, remember last time we have learned that when the molecule have the same functional group, therefore their chemical properties will also be the same. But not for physical properties lah. We are talking about chemical properties. Okay, they will have the same chemical properties if they have the same functional group. Okay, if they differ in terms of functional group, of course, the chemical properties will be different. Okay, all right. So this is the chemical formula. So it can be represented as alcohol. Okay, because we have a functional group of hydroxyl there. Okay, and it can also be represented as ether. Okay, so we have oxygen between the 2 alkyl group. So both of them have different chemical properties and also physical properties because they have different functional group. Okay, all right. Checkpoint 4, draw any three chain isomer of C7H16. Okay, so this is like your homework. Okay, so we are going to proceed to the next slide. Okay, so please complete this checkpoint. We will discuss it next week. Okay, I'm going to proceed to next, which is the stereoisomerism. Okay, this is the new one, the new topic that you will be learning today. Okay, so please make sure that you really understand it. Okay, so stereoisomerism, a molecule having the same molecular, okay, they have the same molecular formula and structural formula. Okay, they have the same molecular formula and structural formula, as in same connectivity of the atom. Okay, but different orientation of atom in space within the molecule. So basically dia punya chemical formula and also structural formula are the same, but they only differ in terms of the orientation of the atom in space, how they are rotating. Okay, how they are rotating in space. Tapi the way dia punya attachment, the atom attachment, connectivity and all that, they are all the same. Compared tadi yang constitutional isomerism tu kan, dia punya connectivity may be different. Okay, mula-mula BR duduk dekat carbon number 2, then suddenly another option we have BR is located at carbon number 3. Okay, for stereoisomerism everything is the same. Everything is the same. Sama, exactly. It's just that the way they rotate ataupun orientation in space. Okay, so there are two types of stereoisomerism. One is known as geometrical, the other one is known as optical isomerism. We are going to cover both of them. Okay, all right, moving on. So geometrical isomerism. Okay, so we're going to go for geometrical isomerism first. Okay, guys. Okay, the structure contains a carbon-carbon double bond, or C double bond C, or cyclic structure that prevents rotation of the carbon atom. Okay, all right. So this geometrical isomerism can only happen if, okay, syarat. You kena tahu syarat. Dan baru you boleh tahu, okay, does this molecule have geometrical isomerism? Okay, not all molecule can have this geometrical isomerism. Okay, you kena determine. Okay, in order to do that, you have to know the rules. In order to have geometrical isomerism, the molecule need to have first carbon-carbon double bond. You need to have double bond. If it is an open chain, this is for open chain, maksudnya yang bukan cyclic lah. Okay, bukan cyclic, maksudnya dia rantai panjang macam tu. Okay, alright. Or it can also be for cyclic. Okay, cyclic can also have geometrical isomerism. Later we will see. Okay, what's the detail of it? This is because the presence of this double bond or cyclic ni, it prevents rotation of the carbon atom. Okay, it prevents rotation of the carbon atom. Okay, look at the example. Okay, all right, we know that this molecule, the atom, okay, they will rotate. Okay, the bond itself will rotate. Dia akan rotate Jangan ingat dia duduk diam, itu dia akan rotate. Dia rotate, dia vibrate, okay, dia bounce. So in this case, dia rotate. If it is a single bond, okay, bila dia rotate, it will produce the same molecule. Okay, it will produce the same molecule. So, so it's not a problem. Okay, it's not a problem. But if it has a double bond, if the molecule has double bond, The problem is that it cannot simply rotate. Dia tak boleh nak rotate simply. Sebab dia dah restricted. Okay? Dia dah restricted to rotate. So it's not the same. Dia bila dah tak boleh rotate, so dia tak boleh macam ni kan. Contohnya CH3 ni dekat atas initially. So bila dia tak boleh rotate, kita tak boleh kata dia sama dengan bila dia duduk dekat bawah. It's not the same. Tapi kalau single bond, okay, due to the rotation, dia kejap dia duduk dekat bawah and kejap dia duduk dekat atas. But it's still the same molecule. Okay, it's still the same molecule. But this one, because of the presence of double bond, it's not the same. Because dia tak boleh rotate. Kalau dia duduk ke atas, dia akan stay dekat atas. Kalau dia duduk dekat bawah, dia akan stay dekat bawah. Okay, not the same as single bond here. Single bond, dia boleh, okay, kejap dia duduk ke atas. And then dia rotate, dia duduk dekat bawah. And then kejap lagi dia rotate, dia duduk dekat atas. Then next, dia duduk kat bawah. Okay, so at the end, dia actually the same molecule. But it's not the same if we have double bond. Okay, that's why orientation dia. So we have the obvious one, saya boleh cakap satu, okay, contoh ni dekat atas, ini dekat bawah. Okay, so it's not simply rotatable lah. Okay, it cannot be rotated. Okay, same goes to cyclic. Cyclic pun problem because dia dah end to end dia dah bercantum kan, end to end dia dah meet. Dia dah meet with the carbon dia meet with one another. So bila nak berpusing tu susah lah dia nak berpusing. It's not as easy as compared to open chain yang tak ada double bond. Okay, so it will be very hard it will be very limited or restricted to rotate. So it's not the same. Kalau dia OH dengan initially dia dekat bawah dengan dekat atas kan. So it's not the same kalau dia duduk dekat bawah dengan dekat bawah. Okay, so dia tak sama. Dia tak boleh rotate. It won't happen this way lah. It cannot just simply rotate to then suddenly dia become dekat bawah. No. Okay, bila berlakunya begini, this creates geometrical isomerism. Maksudnya dia ada keadaan di mana dia duduk same side and dia duduk opposite side. Same goes to this one. Dia boleh duduk same side, keadaan tu, and then the other situation is they both at the opposite side. Okay, so this is what we call geometrical isomerism due to the unrotatable double bond. Okay. Okay, so each carbon double bond or cyclic structure has different molecular weight group of atom. Okay, so since trans-stereoisomerism in alkene and cycloalkanes are not possible if ni syarat dia. Okay. Syarat pertama, in order to have geometrical isomerism, okay guys, you have the molecule need to have double bond. We are talking about open chain. Open chain maksudnya bukan cyclic lah. Kejap lagi kita go for cyclic. Okay, so you need to have double bond, and then secondly, okay, the carbon, so this carbon. Okay, so that is attached to double bond. Dia mesti attached to two different group. It cannot be attached to the same group. Okay, contohnya macam ni. One of the doubly bonded carbon bears two identical substituent. So if this happen, okay, this molecule does not have geometrical isomers. Sebab syarat kedua dia tak obey. Syarat pertama, okay, saya tulis senang sikit. This is for open chain. Maksudnya bukan cyclic. Not cyclic. Must consist of C double bond C. Syarat kedua, okay, the C, the carbon that is doubly bonded, okay, any of the carbon that is doubly bonded, Okay, must not bears ataupun attach to bears to identical, this one lah, identical group. Dia tak boleh. Keep. Okay. Macam ni. Contohnya kan, kita nak identify. Okay, syarat pertama dia pas. Dia ada double bond. How about syarat kedua? Okay, alright, so we check. Okay, for this carbon, see, dia bears ataupun it is attached to two same group. Same goes to this one. It is attached to same hydrogen. We have two hydrogen attached to this to the carbon. So this is not possible. This molecule will not have geometrical isomerism. See? Sebab dia tak obey these two syarat. Okay. This is for open chain. How about for cyclic? Same goes for cyclic. Okay. Alright, it needs to be cyclic. Maksudnya dalam bentuk ring. Then dia tak boleh pegang. Okay, dia tak boleh hold. Any of the carbon in the cyclic cannot hold ataupun cannot be attached to the same substituent ataupun group. See? Okay, we have this one dengan this one kan? Okay, CH3, CH3. No, dia tak boleh. Okay, this one pass. Dia tak semestinya side by side. Untuk cyclic, it is slightly different. It is not necessarily be side by side. Dia boleh this one, this carbon and this one. Boleh. Okay, walaupun dia jauh tak apa. Tapi syarat dia tak boleh pegang the same group. Okay, so that's the syarat for cyclic compound.
Madam.
Yep.
So kalau yang ni kan, yang bawah tu dia ada isomer ke tak? Sebab dia sebelah je kan sama, sebelah lagi tak. So tak ada lah kan? Tak
ada. Dia kena obey syarat dia ni. Okay, kalau case cyclic ni, okay, yang ni pas kan? Yang ni tak pas kan? So dia tak obey syarat yang nombor 2 ni. Okay, so kalau dia tak obey, kalau this one dia kena, okay, kalau cyclic for cyclic, first kena cyclic lah. Cyclic form. Okay, cyclic form pass. Yang kedua, tak boleh pegang ni, exactly the same. Saya paste kat sini exactly the same. So dia ni pass number 1, number 2 dia tak pass. Both of the carbon yang kita nak compare tu must be attached to two different atom ataupun two different group. So dia tak obey these two. Dia tak obey the number 2 rule. Therefore, this cyclic compound, cyclic molecule does not have geometrical isomerism. Okay, alright. So to represent geometrical isomerism, we're going to be using cis-trans. Cis-trans, simple je. Nama belakang sama, exactly the same. It's just that depan tu, one will be called cis, the other one will be called trans. Okay, so kita menggunakan cis dengan trans. Okay, kita akan tengok how to differentiate between cis dengan trans. Okay, but before that, you have to know these two syarat in order for you to determine whether it has geometrical isomerism or not. Okay, so meaning that not all molecule will have geometrical isomerism. Not all double bond can have geometrical isomerism. And not all cyclic molecule will have geometrical isomerism. Geometrical ataupun cis-trans. Okay? Buat apa ni? Sikit lagi saya nak habiskan geometrical isomerism. Okay? And then optical isomerism we will continue next week. Okay, geometrical isomerism. Okay, so this is what I mentioned to you just now. We will use trans and cis. Okay, so this shall be put at the beginning of the name. Paling awal. As you can see, the name is still the same. The name of the molecule will still be the same. It's just that we add in trans and cis at the beginning of the name. Okay, how do we differentiate whether which is trans, which is cis? Okay, all right. So the identical atom. Okay, for trans, the identical atom. Okay, in this case, for this molecule. Okay, the identical atom or group of atom on the opposite side of the double bond. Okay, all right. So macam biasa, before you could have cis and trans, you have to check the two rules just now. Okay, it has double bond. number 1. And then number 2, the carbon must not be attached to 2 same group. Okay, for both, okay, you have to check for both carbon. Okay, carbon number 1 lain, this one pun lain. Carbon number 2, okay, ni group lain, atom lain, ini pun lain. Okay, pass. Okay, that means it will have geometrical isomerism. It will have the cis and trans. Okay, so trans is when the group of atom are located opposite to one another. Opposite to one another. So this is opposite, right? So it is trans. Cis, on the other hand, will be opposite to trans just now. It would be the group of atoms should be located on the same side. Okay, so you just tukar je lah. Satu tadi opposite kan. This one, dia same side. Then it will be called cis. Okay, okay, this is first, contoh, example. Okay, which paling senang lah, you will be based on the position of the same group. CH3, CH3 ataupun hydrogen dengan hydrogen. Okay, but it will not always be this easy lah. Okay, dia tak semudah macam ni. Kita punya molecule will be complicated. Okay, what if we have this type of molecule lah. Okay, ini pun I would say quite easy juga because you can compare in terms of okay, salah. Tak apa. Abaikan apa yang saya just cakap ni. Okay, another example is this tri-substituted or tetra-substituted double bond. Okay, so the reason it is called substituted, normally yang ni kita H kan, H, this one is H. So now it is being replaced with this bulky group. Okay, that's why it is called tri-substituted or tetra-substituted. This is tri-substituted because we have one hydrogen. Tetra-substituted, that means we may have this one like CH2, CH3. This is tetra-substituted. That means all the hydrogen that are supposed to be attached to the carbon are now being replaced with alkyl, with bulky group, with alkyl group. Kami susah lagi nak sebut. Okay, alright. So it is. Okay, so how do we assign? How are we going to assign whether this is a cis or trans? Okay, alright. So macam biasa, you kena check dulu. Dia ni ada tak geometrical isomerism? Okay, bila dah check ada sebab dia ada double bond. And then kita check for each carbon. Okay, each carbon must be attached to 2 different group of atom. Okay, so this is different, this is different. Same goes to this carbon. These two are different group. Okay, pass. So this molecule have geometrical isomerism. Okay, so nak assign cis dengan trans. Okay, you cannot just simply based on this one. Okay, you akan based on, oh, okay, check yang sama. CH3, CH3. Okay, so you pun check CH3 dengan CH3, then it should be trans, kan? Macam kalau you nak pakai contoh yang ni kan. Oh, you check, check yang sama je, senang lah. Okay, kalau yang sama ni trans. Sorry, dia punya group molecule dia CH3 in opposite place, so that then it is called trans. Okay, so no, bukan macam tu sebenarnya. Okay, kita akan based on, kalau macam tu, kalau you based on that, this should be trans kan, tapi kenapa nama dia cis? See, macam ni kan. Kalau you based on the same group kan, same group ni, oh, dia duduk dekat same side. Tapi kenapa dia punya name dia, real name dia, it is trans, not cis. Why? Ni dah, konflik lah ni. Okay, sebab dia bukan based on that sebenarnya. Dia sebenarnya based on this. Okay, molecular weight. Dia sebenarnya based on molecular weight. Okay, alright. So, sikit lagi. Okay. The reason it is named cis isomer because the higher molecular weight group are at the same side. Remember, cis means the groups of atom are located at the same side. Okay, alright. So same site in this case, the higher molecular weight for the first carbon and the second carbon, they are located at the same site. That is why it is called cis. Ataupun lower molecular weight. You can also refer to molecular weight, lower molecular weight. So the lower molecular weight are located on the same site. So bila same site, it is called cis. Okay. On the other hand, trans pula, okay, the higher molecular weight are located on the opposite side. So this is called trans. Trans means opposite. So apa yang opposite? The higher molecular weight are located on the opposite side. Okay, itulah saya kata bahaya if you just based on the same group of atom. Ni macam ni CH3, CH3. Oh, CH3, CH3 sama. So dia duduk opposite. So dia trans. Salah. Okay, so please don't do that. Dia sebenarnya based on molecular weight. Cuba kita pakai style ni untuk this one. Okay, alright. So this one kita identify for this carbon, this is higher molecular weight kan? Betul tak? This is lower molecular weight. Okay, for this one. Okay, for the second carbon, this is lower molecular weight. This is high molecular weight. Okay, so high molecular weight, they are on the opposite side. Therefore, it is called trans. Okay, if we based on the high molecular weight rather than the same group, it is more safer. Okay, so this one, for this carbon, this is the high molecular weight. And this is the lower molecular weight. For this carbon, this is lower molecular weight. This is high molecular weight. So, the high molecular weight are located on the same side. Therefore, it is a cis. Okay? So, macam itulah. You can identify dulu dekat this carbon yang mana high molecular weight. This one. This is lower molecular weight. How about this second carbon? This is high molecular weight. This is lower molecular weight. So, the high molecular weight for both carbon are located on the same side. Therefore, it is called cis. Okay? Right. Okay, lastly, we have cyclic. Cyclic, like I've said to you just now, okay? Dia mesti make sure the two syarat must be obeyed first. Okay, so trans means located on the opposite side. So this is located on the opposite side. Okay, therefore it is called trans. Even though others ni semuanya sama, itu tak kisah. Because cyclic dia punya syarat memang macam tu. Okay, dia ada dua and then dia mesti the same carbon must not be attached to two same group of atom. Macam ni kan? Ni lain, ini lain. Okay lah. Yang ni, ini lain, ini lain. Okay, so kita identify dia cis ke trans macam tu. Okay, alright. So this is cis. This one, okay, wedge dengan dashes. Ini wedge dengan dashes. So this is trans. Okay, so this is trans. This one, apa namanya? Dashes dengan dashes. Okay, dashes dengan dashes. This is cis. Wedge dengan wedge maksudnya same side lah. This shows that they are on the same side. So this is also another example of same side. Okay, same side maksudnya dia boleh dashes, dua-dua dashes ataupun dua-dua wedge. Kalau opposite, satu mesti, kalau trans, one must be wedge, the other one should be dashes. Okay, alright, sebab this one sebenarnya ni kan ada hidrogen yang kita tak nampak, tahu kan? So setiap carbon tu mesti ada 4 bonds attached to it. So OH dengan H, so dia tak samalah. Kan syarat yang kedua tu, dia mesti tak attached to the same group of atom. Okay. Alright, so this is lagi sekali sama je, okay. Geometrical isomers have different chemical and physical properties. Okay, geometrical isomers have different chemical and physical properties, guys. Okay, due to different orientation of atom in space within the molecule. Okay, they may look the same, but dia punya orientation to cause the chemical and physical properties to be different. Okay, so itu memang very interesting lah. Okay, nampak sama, everything looks the same. It's just that orientation je, chemical formula sama, dia punya structural formula pun sama. It's just orientation je berbeza. Tapi perangai dia, chemical properties and physical properties are different. Okay, like this one. Okay, so this is high molecular weight. This is low molecular weight for this one. Okay, so this is low molecular weight for this carbon, and this is high molecular weight for the same carbon. So they are located on the opposite side. Okay, so this is called trans, but the real name is fumaric acid. But for this one, so this is cis lah. Ni sebab lokasi dia punya, they are on the same side, tapi nampak nama dia malic acid, which is totally lain kan, fumaric dengan malic acid. Tapi sebenarnya if IUPAC name, dia differ in terms of trans dengan cis saja. Trans dengan cis saja. Okay, see, nampak dia punya perbezaan dia, kegunaan dia. Fumaric in our daily life, it is an essential metabolite intermediate in both plant and animal. Maksudnya intermediate before they form something else. Okay, very essential lah, very important. But this one, malic acid, on the other hand, is very toxic and irritating to tissues. Nampak tak dia punya perangai berbeza, dia macam yin and yang kat situ. Okay, yin warna hitam, ni warna putih. Yin tu menghadap ke atas, yang tu menghadap ke bawah. Nampak sama, but it's different. Okay, so geometrical isomerism is about cis and trans. Okay, so you have to take note on the two rules that in order for the molecule to have geometrical isomers. Okay, all right. So that is all for for geometrical isomerism. So I believe that we have checkpoints related to geometrical isomerism. Okay, so you may go through it. This one. Yeah, okay, go through untuk cis and trans. Okay, boleh buat dulu for cis and trans. For optical isomerism, we have to postpone to next week. Okay, right, any question related to cis and trans so far? Are you guys following?
Ada nak tanya.
Ya.
Molecular weight tu selalu dia bagi ke? Macam ni kita nak tahu dia molecular weight berapa dia?
You boleh kira kan? You boleh roughly estimate kan? Macam ni yang panjang. See? Kan? Carbon ada berapa? This one 1, 2, 3 carbon. This one we have only 1 carbon. So kalau 3 carbon is already 36. This one 1 carbon. So only 12 kan? So berapa? This one obviously will be higher molecular weight. Kan? Hydrogen, takkan tak tahu satu. And this one, kita kena compare, okay, group yang attached to the same carbon. Nak tahu high molecular weight ataupun low molecular weight. So hydrogen like macam molecular mass dia 1, molecular weight dia 1. CH3, carbon is already 12. And then another 3 hydrogen, it's 15. Kan? So 15 dengan 1. So which one will have? Which one has higher molecular weight? Okay? So macam bromine, iodine kan. So iodine is heavy kan. Iodine is heavy because it's located below bromine. So by right the molar mass atau the molecular weight should be heavier lah than bromine kan. So those kind of thing lah. Maksudnya dia tak perlu bagi molar mass pun. You boleh tahu sendiri from the number of carbon present in the molecule. Okay? Jawab tak soalan tu?
Jawab, Madam.
Okay. Ya.
So maksudnya cis, kalau cis atau trans tu, macam cis tak semestinya dia kena sama duduk kat bawah lah. So duduk atas sama, duduk atas pun boleh?
Ya, boleh. Boleh, asalkan dia same side. Ni, sebab contoh kat bawah Oh. Okay. Alright. Contoh kat bawah. Okay, ni pun ni kat bawah. Okay, alright. This one pun dia dekat bawah, dekat same side kan. Ini kat atas. Sis. Okay. This one. Sis tu syarat dia same side. Can either be both at the top ataupun both at the bottom. Okay. Macam ni kan. Ini kan low molecular weight. Low molecular weight. So, if you are referring to low molecular weight, that means dia dekat bawah. Tapi same side. Dia punya highlight will be same side. If we are referring to high molecular weight, dia dekat atas. Tapi same side kan. Bila same side, it will be cis lah. Okay, it will be cis. Same goes to this one. Kalau dia opposite, tak mesti dia opposite dekat sini je. Dia boleh opposite dekat sini. As long as dia opposite. So that's why dia tak specify. Opposite mesti belah kanan. Opposite mesti belah kiri. Not necessarily. Both can be accepted. Okay. Alright. Any other question? Okay. Ada Okay. Alright. So this is very important. Okay. Sebab exam suka juga tanya jenis geometrical isomerism ni. Okay. If there's no question, I think that's about it for today. So thank you everyone for your kind attention and cooperation. Okay, so see you during tutorial. Okay, Assalamualaikum. Bye-bye.
Thank you, madam.
Thank you.
Thank you,
Madam.
madam.
Thank you.
Okay, madam.